So moving on to the next section related to understanding the device. So the device, as we were mentioning earlier, has, well, it looks like this when it's all put together. Some other additional sensors can be connected through this port, as I was mentioning, either expansions for air quality, GPS, or water quality. It has this button as shown in the picture, which is the on-off button that basically is used for turning on or off the kit and also changing the mode of operation. So if the Smart Citizen kit is off, by clicking this button, just a short click, it will turn on the device. If the Smart Citizen kit is on and we click the button, it will change the mode of operation. We will see what the different modes are in the next slides, but basically we can just use this button to change the mode. If it's on and we press the button for 5 seconds, so we perform a long press for 5 seconds, it will turn the kit off. And as soon as we press or click the button again, it will turn it on. And then if we do so, a long press for 15 seconds, so we go beyond, even if the kit is off, we keep on pressing for 10 more seconds, it will default reset the default settings. So all the Wi-Fi passwords, well, Wi-Fi connection settings, the password and the device token, it will be erased. And we will also default to the default reading and publication interval. The reset button, we call it a magical reset button because it basically is the first option in case our kit stop sending data to the platform. We see that there's a problem with the device and the LED is static. We don't know what's going on. It's the first place to just click this button and reset it. In here, it might be a little bit inaccessible, and we have recently made connectors so that we can access the reset button from outside the enclosure. Probably in some enclosures in the past, it was not so accessible, but now there's some holes that we can, for instance, insert a pen or a screwdriver to reset the kit. Basically, what it does is reset the kit and just does a hardware reset, let's say, so it boots and starts everything from a fresh start. But if we double click it, we will put it in what we call massive storage mode, which means it's a way for us to upgrade the device. And if we have connected the Smart Citizen kit to our computer via USB and we double click this button, we will see as if we had connected a USB drive. And then we can simply drag and drop a firmware or a new code for the sensors so that it updates. And we do this fairly frequently to improve robustness and on other aspects. So it's a good and simple way for doing it. It takes less than 5 minutes to do the whole process. If we double click it, we will see that the LED will turn green. It's one of the special reserved colors for the LED, as we will see in the next slides. And if you do it by accident, don't worry, because you can double click, you will turn green. And then if you click again, it will start over and resume normal operation. So if you, for whatever reason, see a green LED, just simply by pressing the reset button, it will be restarted from a fresh start. So now, talking about the famous status LED, it reflects the status or the state of the device. It's an RGB LED, so it has different colors. The basic setup or the basic mode is what we call the setup mode, which is reflected in a red LED. The blue LED will reflect Wi-Fi connection, so it will be sending data to the platform if everything goes right. The sensor will be basically breathing in a blue color, and if we are just storing the data on an SD card, it means that the LED will be in pink. So 3 basic modes: red for setup, blue for Wi-Fi or online mode, and pink for offline or SD card mode. As we were saying earlier, just by simply clicking the on-off button, we can move from mode to mode, and we will always come back to the mode that is configured. So if we started configuring the sensor to post data online via Wi-Fi, if we click the on-off button, we will go to setup mode. We can configure the sensor, or if we don't want to configure it and we change our mind, we can click again, and then we come back to Wi-Fi mode. For instance, this is useful when the device is changing home, we could say, because we can either just give the sensor someone else and they can just click the button and then it will turn red and they are ready to configure it. Otherwise, we can press for 15 seconds and it will reset the defaults. So there would be no compromise of sharing Wi-Fi's or things like this. And the device will be breathing in, the LED will be breathing red. And when I say breathing, it means that it's a very slow pulsing, let's say, intensity change on the LED itself. On top of these colors that I was just mentioning, the LED also reflects the the state of the battery. So if the battery is connected and the USB is connected, and we see orange flashes on the LED on top of the other blue, pink, or red colors. So if we see orange flashes on top of those colors, it means that the battery is charging. If we see green flashes, then it means that the battery is fully charged. So it's already, if we were charging it, we can unplug the USB and already use it for whatever deployment we have. In case that the USB is not connected, then and the battery is on, is there, of course, then the orange flashes don't mean that the device is charging, but that is has low battery. So whenever we see that the device is unplugged from the USB and there's orange flashes on the LED, it means that it has low battery and it will soon turn off as a safety precaution. Finally, of course, if the USB is not connected and there's no indication in either of these colors, either orange or green, then basically it means that there's absolutely no problem and that the device is working and operating in principle normally. Finally, as well, and even if it's not shown here, but if there's no indication on the LED for a certain amount of time, like 3 or 5 seconds, and then you see some flashes, for instance, like occasional flash on blue or in pink, it means that the sensor is still working, but that is what we call it in sleep mode, meaning that it's basically turned off for 3 or 5 seconds to save battery, and then it turns itself on, measures whatever it needs to measure, sends data to the platform if it has to, and then it turns itself off back again to save battery. So even if the sensor doesn't show any feedback and everything is connected, the USB there, and you just see occasional flashes on the LED, it means that the sensor is sleeping, and we do so for saving battery and extending, let's say, as well the battery duration, of course. So important things to remember, basically, when you first start, the LED should be red. So the SDK or the Smart Citizen Kit is in what we call setup mode. In setup mode, the kit is waiting to be configured and it won't record any data until you tell it to. So it basically is waiting for you to tell it what to do. It won't sleep in that situation. It will charge the battery and it will do everything else, but it won't record any data. Once you get it in setup mode, you can choose. Either you send the data over to a platform and the LED will be blue, or you keep it on the SD card and the LED will be pink. Finally, even, sorry, if the LED is in either blue or pink and you need to change the configuration, you can just click the button, set up, you are back in setup mode, and then you are ready to go to store data or change the configuration and send the data to another Wi-Fi connection or another device on the platform, or finally just change the mode and go to SD card in case that you don't want to send it online. So some considerations about the different modes. The Wi-Fi mode Of course, it's sending data over to the online platform that you very well know already. If there's an SD card inserted and the SD card doesn't have any problem, the data will be also stored in the SD card, and we will see how the format is stored in there in a second. But basically, the data is sent over to the platform through a Wi-Fi connection. That Wi-Fi connection can be one of these type of networks, WEP, WPA, WPA2 personal, which are the normal networks that you find in domestic environments or small businesses. It cannot use other platforms or other Wi-Fi's like EduRoam. This is very common in Europe, or VPA2 enterprise networks, such as the ones that we find on airports, libraries, restaurants, some things like that, because basically these networks offer normally a captive portal that is a little difficult to handle for the device. So we don't support that type of network. So for normal cases, domestic environments or small businesses is fine. Otherwise, you can set the sensor or the device in SD card mode, in offline mode, and then data will be sent. You can send the data to the platform from your computer later on by just taking the SD card and uploading the data, as we will see. Something important here to distinguish is the difference between what we call the platform device and the hardware device. So the platform device has what we call a device ID, which is this URL that you are aware of already, is smartcitizen.me/kids/a number. That URL or that number at the end is the device ID. So it would be a number, something like 15,000, etc., etc. So that device ID is basically the number of your device that has also a name and a user, and it has a location in which you pinpoint it to. It also has a token attached to it. So normally this token is a 6-letter token, letters and numbers actually, that we will get from the onboarding process. We will see that in the following slides. It's a way for the device, the hardware device, to authenticize itself versus the platform. So basically, this token identifies the data that is being sent from this particular hardware to the platform. But this token can be reused. So you can share this token, or you can use this token once and then change the token and then come back to that token again. And the device on the platform will basically store that data. The only thing is that it should only, this token, since it's linked to a device ID and ideally to just one piece of hardware, should only be linked with one device at a time. So meaning not more than one kit should be sending data to one device online. Otherwise, you will just crossing data. Finally, the hardware device itself needs this token. So we will input this token that the platform gives us to send the data over to our platform. And then this token can be changed as many times as needed. And this will generate another device on the platform. And at any time, you can just create a new one. And there's no limitation for that. So basically, as long as you just keep one token at a time on one device and there's no other option, you can change it as many times as you need and store the data in different places on the platform with the, let's say, onboarding process that we will see in a second. What happens if you, for whatever reason, have an unstable Wi-Fi, or you have a device that is mounted on a bicycle or on something that is moving, and that is moving away from the Wi-Fi hotspot? So imagine that you have the sensors located near your home, university, or wherever they are located, and then you go on a trip because you want to measure around in the city, and then you come back. If you have the sensor set up in Wi-Fi mode and you're moving away from the Wi-Fi hotspot, is no problem. The data during your trip will be stored locally in the device, and then as soon as you come back to the hotspot, the Wi-Fi hotspot, then you will the device will send the data automatically in batch. So it will record during the whole trip, and as soon as you come back and it sees the Wi-Fi again, this data will be sent automatically. If you're moving and you have a GPS attached, which you can do as well if you want to measure dynamically around in the city or on the sea in some particular cases, the recording interval will be set automatically to 5 seconds. So when you're moving, since we assume that you want to record more data, then the recording interval will be set to 5 seconds, and it will be the default 1 minute otherwise, or whatever you have set the recording interval to. This is, as I was saying, useful for mobile applications or for applications in which you don't have Wi-Fi. And for instance, with your phone, you can make a mobile hotspot and then give Wi-Fi occasionally. So the sensor can just store the data on board. And then once you go with your phone, you turn on the mobile hotspot, and the sensor will connect to it and send the data. And it's quite useful for deployments in which you don't have this type of, let's say, standard Wi-Fi available. As well, it provides robustness in general, because in case that the Wi-Fi connection is lost for some minutes, the data will be stored on the device, and then it will be automatically republished, and you will not have to do the process manually after that, afterwards, by sending the data to the platform by yourself. The SD card mode, it's quite simple. There's a couple of considerations to take into account. The data is stored on the SD card in a CSV format. It will create a CSV file. A CSV file is just a tabular format that we can analyze with a spreadsheet program. So it will create one CSV file per day with this date format. So you can guess the date in which that data was taken out by the name of the file itself. And then with any spreadsheet program, you can open this data from the SD cards. You can just plug the SD card on your computer and then analyze it and have a look at it. However, we recommend to use, for instance, our dashboard or other scripts or analysis programs in case that you have a lot of data. For instance, data that is, for instance, more than a week of data, it will be maybe a little bit complex to analyze with Excel or something similar. So it's better if you can use another way. And one of those ways would be simply to just upload the data to the platform and have a look at it there, or use a more advanced scripting language in case that you have a lot of data. Otherwise, it can be a little bit difficult, especially if you have a lot of CSVs that you have to handle. The final consideration for all these aspects related to operation modes is that the sensor, or well, the Smart Citizen Kit needs to know the time, of course, so that it's able to attach the sensor readings that is taken to a timestamp. So we will read all the sensors, and then we need to know basically what time it is. So basically the day, the date, and an hour. And it does so either when we configure the sensor for the first time with our phone, or it takes the time from an online server. So if we have the sensor configured with Wi-Fi, it will automatically ask what time it is to the internet. Important to know, just one particularity is that the internal clock, its in technical terms is real-time clock, or RTC, needs to be always powered, which means that if we don't have USB power and we don't have a battery, or we run out of battery, then it is that the sensor or the kit will lose the time, and we have to give it back to it, otherwise it will complain. How will it complain? With the LED, the status LED that we saw earlier, it will be in error mode, which means that it's flashing fast. It's not such a nice, breathing, smooth change, but it's flashing very fast. And basically that means that the sensor, well, that the device is not taking data because it doesn't know what time it is. This probably is familiar, you will be familiar with some phones from maybe 15, 20 years ago that when you remove the battery and you turn them on again, then you have to tell them, oh, is this time and date, and I'm located in whatever. So this is something is similar. The only particularity is that if you have a Wi-Fi connect already configured, then the sensor will recover the time from the internet. Otherwise, it will complain. And in that regard, with the error mode, we just saw it. This error mode means that the sensor cannot log any data. So if it doesn't have Wi-Fi and you change it from one place to another, it runs out of battery, then it will be flashing very fast and it will complain. So you have to configure the device again with the onboarding process. If the device is not flashing very aggressively, but is what we call a mild flash. So it's it would be what we call in the warning mode, meaning that the sensor is still collecting data, but either the Wi-Fi connection is lost or the SD card is extracted. So it can still collect data, it can log it because it has time, basically knows the date and it has access to the sensors, but it won't be able to send the data to the platform or to store the data on the SD card. So it will it will just give you a warning, and that warning is shown with the LED flashing mildly or like not very aggressively, let's say. This is useful. This warning mode is the mode that we will see most of the time when we have the kit on a mobile setup. So we are collecting data, we move away from the Wi-Fi hotspot, and then we lose Wi-Fi connection. Then the LED will be giving us a warning telling us, hey, I don't see the Wi-Fi, but I'm gonna still collect data. If it runs out of power and it doesn't see Wi-Fi and then it can't log data, then it will move on to the error mode, and basically we will need to reconfigure the sensor again so that it's able to collect the data and go back to normal operation.